So I wanted to um, uh, describe and talk a little bit about this project that I've come up with for my SeaArk. My SeaArk currently has a live well on it with an aerator that pumps water into the live well, and it's powered by a 12-volt cranking battery. My concern, though, is that when I have bait in the live well, that if the pump runs continuously as it's currently designed, that it will drain the power of my battery, and cause me problems with cranking the motor. So I have come up with an idea to use an ESP32 to create a timer that I can control through a Wi-Fi connection and web page on my phone. And the way I'm going to do that is with this ESP module that you see here. It has Wi-Fi and Bluetooth. Wi-Fi is what I'm more familiar with. Bluetooth may be something I do later on, but I'm more familiar with the setup of Wi-Fi on this chip, and on the software side of things, software development side, I'm somewhat familiar with using WebSockets over a TCP/IP connection that's available through the Wi-Fi network. And what I've got here is a circuit, several several circuits that I have put together to integrate the components I need to control the pump. And I've got, I've got LEDs. Excuse me. I've got some LEDs that help me indicate the different statuses and states that the ESP is in. The big blue one here lets me know that the Wi-Fi network is up and running. The Wi-Fi network is called SeaArk Livewell. I'll show you that in a minute. And then the small tiny blue light here lets me know that when I refresh my web page or bring up the web page, it lets me know that it's connected to the web server that's running on this ESP. I've also got red LED to let me know that the ESP is receiving power, and then down here in the bottom right is what I'm using to simulate turning on and off a pump. And then the next components I've got on here is this relay. It's not the one I'm going to use when I actually put it in the boat. It's just one to test with right now. But this is the relay that I've got added here. It's a single pole double throw, and I've got it connected to one of the GPIO ports on the ESP board. And one thing to note about that is I've had to connect it to GPIO 2 on the ESP. That's the only GPIO that starts up connected to ground when the ESP boots. Otherwise, if it connected to the power side, the pump would start up when I actually booted the chip. So I'm using GPIO 2 for that. And between the relay and the GPIO, I have a 330 ohm resistor, which is also connected to an NPN transistor to gate the power, or powering the actual relay. I cannot remember what the model number of this, or the part number of this transistor is. It's an NPN transistor. And then if you look closely, I've got a diode. That's an IN4007 diode to handle the induction the induction kickback coming from the coil and the relay. I've also got to add a diode on this side here that will be connected to the pump, but I haven't done that yet. That'll come in my next iteration of the build. So that's the hardware side. There's also a buck converter here that I'm using that I've got 12 volts coming in and 3.4 going out to power the ESP, and then you can see the milliamps being consumed as the ESP turns on and off. It's like 14 milliamps when it's off, and then 25 milliamps when the relay turns on. So that's the hardware side. For the software side, this is what I've got going on here. I need to switch hands. So for the software side, you can see here the number of seconds that the pump is on, and the number of seconds that the pump is off. And it's just feeding this information out to serially so I can confirm what's going on with the code. This web page here represents the web app that I've written to allow me to control the pump from my phone wirelessly over Wi-Fi. I've got an on and off switch here. So when I cut that guy off, I have got to refresh. There it goes. I hadn't refreshed my page, I don't think. So I can cut it on and off with this switch here. And you can see the log files there as I cut it on and off. That's in an off state, and then that's in an on state. And on state, you can see the log files there. I can also adjust the time. So as I adjust that down, you can see the log files telling me that it was just down to 5. Actually, this is in seconds right now. I'll change it to minutes when I'm ready to put it in the boat. But I can adjust this down to on time of 2 seconds, off time of 9. And let me adjust this so you can see. So there's the log file being changed, and now you can see a different rate. So it's off for 4 seconds and on for 2. So we'll count here. Off 1, 2, 4. Yep. Actually, I think it's 5 seconds. But anyway, you get the idea. So that changes the rate. And I can actually lower it down. Let's see. I'll make it flash on and off. There it goes. So that's actually 1 second on, 1 second off. And then I can scale it all the way up to 10 seconds. Oh, maybe I missed that video there. So it's 10 seconds. So now it'll be off for 10 seconds. And then it'll be on for 10 seconds. So, and the reason I've set it up that way is I kind of think that at different times of the year, the pump doesn't need to run as much as it does between winter and summer. And in summer, there's kind of less oxygen in the water, so you have to stir it up a little bit more. So the pump will need to run more. In the winter, that's not necessarily the case. So having this feature here allow me to adjust the timing on the aerator when it runs and when it doesn't run. So another neat feature here that I've built in is the ability to remember the state of the ESP once it's turned off and turned back on. So what I'm going to show you now is it's in a run on state, and I will actually power everything off here. And I'm just going to unplug it. So everything's powered off, and now I will power it back on. And you can see that it's going to come back up in the same state that it was in when I powered it off. It's going to be, let's see, off for 4 seconds there, and then on for 7. Yeah, there it goes. You can see the output there, and I can also make sure I'm still in the SeaArk. Yeah, so there's the SeaArk wireless, the Wi-Fi network that I'm connected to. And if I refresh this page, once it comes back, you'll see it pull in. It takes it a while. I've got to fix that, but once it comes back up, it comes back in the state that it was turned off at. And I'll just show you how it does on the off. So everything's turned off now. And now I'll repower it again. So everything's off. And now I powered it back up, and if you notice, the LED is not on. And if you look here, you can see that it has booted, and it's telling me that the state of the pump is off, and that the on time is 4 seconds in this case, and 7 minutes. On time is 4 seconds, and off time is 7. And if I refresh here, let me make sure I'm back on the network. Yep, back on it. And then I'll refresh here. And then it's in the off state with 4 to 7 seconds for the on-off times. And I just turn it back on, and it starts back up. And you can see it's off for seconds, and then it'll start coming back on. Let's see, actually off for 7 seconds, and on for 4. So, pretty cool. My next step is to turn what I've got designed here on the breadboard into something that I can actually start putting some components in and actually hook it up to the pump. This is another board that I'll be using that's got the ESP32 that I've already soldered on, and then I'll take the components that you see on this board here and move it to this board and give me something that I can actually put in the boat and start testing out in the field, so to speak. So that's the project at the current state that it's in, and again, I just wanted to document this via video so I can have a recording of it, and then also share it with people who might want to see it on my YouTube channel. If you have any questions, just leave it in the comments. Thank you.